Hello. In this video I'm going to go ahead and rebuild the HDMI switch that I broke in the first part. It just came in today, and so let's get started. I started off by opening up the parts bags and setting up my work area. I didn't really need any of the extra jumpers, just the pin header strips that came with the Node MCU. I went ahead and inserted the pin header strips into the Node MCU. Once I had those in, I went ahead and inserted the Node MCU into the perf board so that I could go ahead and start soldering that. I went ahead and heated up my soldering iron and then carefully went through each of the pins and applied a little bit of solder. I started off by applying some solder in the corners so that it would be nice and stable, and then I applied it to the rest of the pins. Once that was done, I went ahead and I flipped the board over and I did the same thing to this side. Next, I went ahead and grabbed a resistor. I bent the pins over so that it would fit into the board, and then I inserted it between the TX and D2 pins. Then I flipped the board over and I bent the resistor lead that was next to the TX pin so that it was actually touching the RX pin. I realized I had forgotten to clip the pins of the mini Node MCU, so I went ahead and did that, making sure to move the leads of the resistor out of the way. Next, I went ahead and I soldered on the resistor and the diode. I have placed a link to my Github account in the description where you can check out the schematic. After soldering, I went ahead and I clipped the leads short so they were flush against the board. Next, it was time to add the 2-pin header, so I carefully positioned the board so that the pin header was right above the jumper, which gave it just enough space. Then I applied a little bit of solder. I lifted the board and I held the pin header in my finger so that I was pushing a little bit of pressure on it while I heated it up again and let it pop right into place. Next, I grabbed the HDMI switch and I proceeded to remove the screws and take the cover off. I took the board out and I decided to inspect it to make sure it looked good. After I was sure everything looked good, I went ahead and I grabbed the wires that I had previously removed from the old unit. Next, I applied a little bit of solder to each of the points where I was going to attach wires. And then one by one I stripped the wires so there was a little bit of wire exposed, and I tinned them with some solder. After that, I trimmed them down to about 2 millimeters, which gives them just the right amount of wire to attach to the tiny resistors. It was a little bit tight, so getting the soldering iron in at the right angle took a little bit of experimentation. After I had the wires attached to the 4 status LEDs, I went ahead and I soldered a wire to the place where I could check the power status of the device. And then I attached a wire to a lead of the button so I could simulate button presses to change different inputs. The wires on the original device were a little bit higher gauge than I would have liked, so I went ahead and removed the outer insulation from a section of cable so I could get access to the wires inside. Then I removed the inner cable shielding, and voila, I had access to 25 different 26 gauge wires. After selecting a black and red wire, I took that red wire and I stripped the insulation off and tinned it and cut it a little bit shorter so that I could solder it to the plus 5 volts. I went ahead and did the same thing with the ground wire. Now that I had all the wires soldered, I cut several strips of Kapton tape and applied them over the wires to attach them to the board. I chose Kapton tape because it is non-conductive and it works really well for circuit boards and doesn't melt with any heat. After that, I went ahead and I prepared each of the wires by stripping them and twisting them as well. Then I applied a small amount of solder to each wire so that they would be easy to solder to the perf board that I had prepared earlier. I decided to go with the button wire first because it was the most complicated one to attach. Next, I attached the power status LED wire to the board, followed by the ground wire. For this one, I attached a bridge of solder that ran from the 2-pin header to the ground pin of the mini node MCU, with the ground wire in between both of those. And then I soldered one of the extra resistor leads from the other pin of the 2-pin header over to the D3 pin of the mini node MCU. Next, I soldered the 5-volt wire to the node MCU. I chose to do the 5-volt wire and use the onboard voltage regulator rather than the one on the board because I was afraid it would put a little bit too much strain on the HDMI switch. After that, I went ahead and I soldered the remaining LED status wires onto the other side of the node MCU. Unfortunately, while trying to solder one of the wires, it slipped out right before the solder hardened, and I had to use a solder sucker to fix that. After I had finished soldering all the wires, I pulled out my continuity tester and I made sure there weren't any short circuits. All was good. Next, I pulled out a micro USB cable to go ahead and program it, but I realized it wouldn't quite fit in. The board was a little bit closer than the old one. So I pulled out my Dremel tool and I very carefully cut the board very close to the node MCU, being careful not to cut into the micro USB port. Once that was trimmed, I attempted to plug the cord in, and this time it fit wonderfully. Next, I pushed the button several times just to make sure that the input on the HDMI switch was still working. After restarting the computer because it wasn't showing up in the Arduino IDE, I was able to successfully upload the code to the device. I connected directly to the access point with my computer and set it up, but I was having some issues, so I went ahead and reset the node MCU again. After powering on, I placed the jumper over the 2-pin header for about 10 seconds and then pulled it off, and it showed up as a Wi-Fi access point. The reason I had to reprogram it is because I had entered the MQTT device name incorrectly, and after looking at my MQTT settings, I found the correct spelling and re-entered that. Next, I pulled up OpenHab and I went through and tested each of the channels by pushing the buttons, and then finally I went ahead and tested the power to check whether it turned on or off, and it was successful. As a final test, I decided to check it out with Alexa and power cycle through all the different settings. Sweet! It works! Next, I placed several pieces of electrical tape over the end of the board so that it wouldn't conduct with the case or the circuit board underneath. I placed the circuit board back inside the case, and then I placed the top on it. Since I'm using the top from the first build that already had tape on it, I won't worry about it. However, once I actually placed the top on, I realized it wasn't fitting quite as nicely as the first build. After playing around with the positioning of the circuit board, I realized this was the best fit. So I went ahead and I started placing all the screws inside of it. I finished tightening all the screws and realized there was a slight gap in the case right here. I decided that this was about the best it was going to get and it would function just fine. Okay, it was a successful build. I did learn a few things during this build. First of all, you don't need the jumper on to program it. Second of all, When I originally built the first one, I accidentally had soldered it in with the board upside down, and I just kind of went with it. But it actually ended up being a good thing because, first of all, it raised the USB port up, so I didn't have to cut off the board like I did on this one. And it also has a little lower profile, so it fits better. With this one, it's a little more squished in, so it's bowing just a hair. But that's okay, it functions. I'm very happy with the build, and I hope you enjoyed part 2. Don't forget to like this video and subscribe, and remember to click that bell icon so that you will get notified of any of my future videos. And feel free to share this video as well. And I'm going to go ahead and link part 1 in case you missed it. Thanks.